We're going to be looking at this new section, indexing structures for files. We have single level ordered indexes, the structure, and this is for a ordered index file. It's small and easy to do a binary search. We have a list of pointers to disk blocks. We have a dense index versus a sparse index, which is where it's non-dense. And dense means that one index entry for every record of data files, and sparse is that it has index entries for only some of the search values. So this is what it's going to look like. We have multiple different ways we can index. There's primary indexing, clustering indexing, and secondary indexing. So we have these fields, and inside of these fields, they're going to be related to data files. So whatever field we specify will take us to a different data file. So let's say we scroll down to this example right here, and instead of using names, we use numbers. Like let's say this is number 1. Instead of Aaron, this is 1. And Adams is 5. And let's say we want to look for number 4. Well, we're obviously not going to look into this next field pointer right here. We don't need to look into these data values here because we know it starts at 5. We know since the first one starts at 1, next one starts at 5, it has to be in the first block. So we're only going to be looking at the first block. So that's how that would work. It's kind of what this is showing right here. Next we have primary indexes. It's specified on the ordering key field of an ordered file of records. Ordering key field is used to physically order the file records on disk. Index file consists of index entries, or the index record. We have the index entry, and the index entry is the primary key, and then the pointer to the disk block. So in here, on the left, we have our primary keys, and then they point to our disks. Then we have our index entry, which is basically a key and value. We have one index entry, one block in the data file. We have anchor records of the block anchor, and this is the first record in each block of our data file. So if we look at this, we can see it is ordered by name here. Next we have accessing a record. With accessing a record, we have load blocks of index files. We want to search in our index files. We have load corresponding data files. There's the average time to access a record, and to calculate this, we're going to look over some examples. We have our B, which is the block size, R, which is the record size, and a little r, which is the total number of records. The blocking factor, which is the BFR, is equal to our B divided by our R, records per block. A file has a B block if B is equal to our R, so the total number of records divided by our B, which is our BFR. I actually read that a little bit wrong, so R divided by BFR, not just B. And remember, BFR is B divided by R. So this is basically R, little r, divided by B divided by R. And if you rewrite this, it's probably going to be something like little r times R, big R, divided by RB. Now we have a file with a B block. It's binary search to find a specific record, and it needs to access the logic to B block. And I think this 2 right here should actually be down here. So log base 2b. And this is for a linear search. If we do linear search, it's going to be b divided by 2. Let's look at an example. This is actually a little bit incorrect. We're told how many block accesses are needed for a binary search on the data file. Well, for getting our block accesses, we can use our binary search. And to do this, we're going to have our log base 2b. So I specified that here. We should also specify that this is a binary search like this. So now that we know this is a binary search, we can say that if we plug this into a calculator, we have log base 2 over b, and our b is equal to our r over BFR, which is b over r. So we can essentially say that we have our log base 2, and then inside of here, we're going to have our little r times our uppercase R divided by our uppercase b. Given the values that we have, this is going to be 11.5. If we round this up, it should be 12. So we have 12 because we can use binary search. And then we want to use primary indexing. Well, if we have our primary index, we want to order a key field v, it has 9 bytes, and we have a block pointer p is equal to 6 bytes. Well, one index is going to be one block. And so if we have 6, we're going to have 6 blocks. And then we need one more so that we can include this. So that's going to give us 7. So it's going to take 6 to search our index. And that is how we will look at our average time to access a record. For clustering indexes, files are physically ordered on non-key fields. These are like cluster fields. So that means they're not reliant on a key. A clustering field does not require to have a distinct value. So we're going to have a clustering index where we have our index field and pointer. We also have a one entry for each distinct value of the clustering field. So we have our index file, we have our clustering fields, and then we have our pointers after this. And this points to different data files. And these fields are going to determine which data files they point to. If it's 1, it'll be in this first one, 2 will be in this second one, and 3 will be in this third one. We can see that it's non-key based. With insertion, we want to see how to make insertion more efficient. It's common to reserve a whole block or a clustering of contiguous blocks for each value of our clustering field. This figure translates into what we have here. Note for number 3, we can have these blocks, or we can have it kind of connect to other blocks as well. Let's look at secondary indexes. These are just like primary indexes. However, if we look back at this example right here, we can see our primary index, the key, is our name. Well, we can make another primary index if we were just looking at like this, and it would be the social security number. That would be like the second index. So we have two things that we're like kind of filtering. Think about it like that. It provides a secondary means of accessing a file for where some primary access already exists. We have our index entry, we have the index field, which is non-ordering field of the data file. We have our pointer, which is either a block pointer or a record pointer. We have our secondary key, which is the index file, and it has a distinct value for each record, one index entry for each record in our data file. And then we have dense indexing, which we'll look at in a second. This is pretty dense right here, where we have these index fields and we have these blocks, and they point to these specific blocks. We can see like for this first one, it's going to point to 24, this next one points to 21, and then the third points to like 6, and we can just keep going down, and these all point to different things. This is very dense. So let's look at an example that we looked at previously. If we have a linear search of here, it requires b divided by 2, so that's 3000 divided by 2, so 1500 block accesses on average to do this by a linear search. Now the secondary index is on a non-ordering key field, so if we have our v is 9 and our p is 6, only 10 is needed, so it's smaller and it's in order. Now let's look at our secondary index on a non-key field. Numerous records in the data file can have the same value for the indexing field. So we have options for implementation, so several index entries with the same k value or for each one record. So like you can think about it like we have this one right here, it's going to go to this one. We have this 2, it goes to this 2, but we have this other one right here, and it goes to this one. So they're basically matched, and it's just, we have these same index values, and they go to different records. We have variable length records for index entries. So this is where we have some kind of like index right here, and then we have different slots in them where they all map to different types of like data files. And then we have another one where it points to a block of record pointers. So if some k occurs and there's too many records, we can't fit the pointers, we're going to use something like this, where we have these field values, we have these block pointers, and they point to blocks of record pointers. And so these pointers, these original ones, are going to point to pointers that point to other things. So that's how we can access it. Let's look at an example. So we have our data file, we have student, and then we have the fact that it's ordered based on our student ID. We have our student ID, name, and address. Can we implement a primary index? We can. Our primary index can be the student ID. Can we implement this with a cluster? No, because it's ordered based on the student ID, so it's a key. We can't do any of that. Next we have, can we do a secondary index? If so, which field? Yes, we can, because if we have a first index and we have multiple other things, we can do a secondary index. So that's done with our single level indexings. Next we have multi-level indexings. But these are in the notes linked in the playlist below, like button. We're just going over more of things here. And then we also have some extra stuff with like 10, 11, 12, and 13 chapters, and they can all be found in these PowerPoints. They're not mine, but my professor's. So thank you for that.